Many of us, when we look at skyscrapers, those massive buildings that seem to touch the sky, can't help but feel amazed. Take the Burj Khalifa, for example. It stands at a jaw-dropping 828 meters tall. To help you imagine how tall that really is, consider this. The Great Pyramid of Giza, one of the 7 wonders of the ancient world, is only about 177 meters tall. That means you'd need nearly 5 pyramids stacked on top of each other to reach the height of the Burj Khalifa. So here's the question. How do these giant buildings stay standing without collapsing or facing serious problems? Welcome to Chronix. Before we dive in, make sure to hit subscribe and turn on the notification bell so you never miss a video. After the end of the American Civil War in 1865, people started moving in huge numbers to major cities like New York and Chicago. This sudden wave of urban migration caused a serious problem. Cities were running out of space. The land was limited, but the population kept growing. That's when a new idea began to emerge. Why expand outward when we can build upward? Instead of building 10 separate 4-story buildings side by side, why not build one 40-story building in the same footprint? It made perfect sense, at least on paper. But at the time, people were terrified of tall buildings. They thought the higher a building went, the more unstable it would be, and the more likely it would collapse. Still, with space running out and the population booming, cities had no choice but to experiment with vertical construction. They started building skyscrapers and solving problems as they came up. The first skyscraper and the 2 big challenges. As engineers moved forward, they finally managed to build what's considered the first modern skyscraper. The Home Insurance Building in Chicago, completed in 1885. But how exactly did they pull it off? And what challenges did they face along the way? Any skyscraper comes with 2 major problems. How do you keep the building from collapsing under its own weight? How do you make it stand strong against wind and earthquakes? Let's start with the first one. Every structure in the world is under constant pressure from different types of loads, like the weight of its foundation, the people inside, the furniture, and more. But there's also a massive hidden load, the building's own weight. In engineering, this is known as the dead load. It includes the weight of concrete slabs, walls, columns, tiles, ceramic, even the sand used under the flooring. The entire structure needs to be designed to support these weights 24/7, because if the load ever exceeds what the building can handle, it will collapse. Now for the second issue, wind and earthquakes. You might be surprised, but for tall buildings, wind is often a bigger threat than earthquakes. Here's why. The taller a building is, the more surface area it exposes to wind. And at high altitudes, wind speeds can reach up to 120 kilometers per hour. These strong gusts don't hit just one part of the building. They hit every part, and they hit constantly. This ongoing pressure creates vibrations and swaying. If the structure isn't built to handle that, the results can be catastrophic. That's why engineers always factor in wind loads when designing skyscrapers. Ignoring them isn't just risky, it's deadly. How do skyscrapers actually stay standing? To begin with, engineers calculate the total loads of a skyscraper with extreme precision, often adding hundreds of extra tons to the total estimated weight just to be safe. So, after facing all these massive engineering challenges, how did they overcome them? The first big solution was simple but genius: deep, reinforced foundations. Engineers start by digging deep into the ground until they reach solid, stable layers of soil. Without this step, the whole structure would be at risk. If the soil underneath a building is weak, the entire building can tilt, or even collapse. One of the most famous examples, the Leaning Tower of Pisa. Structurally, the tower was well designed, but the big mistake? The soil beneath it wasn't strong enough. That's why it started to lean and still does today. So, what happens if the soil isn't strong enough? You reinforce it. That's exactly what engineers did with the Burj Khalifa, the tallest building in the world at 828 meters. Fun fact, the empty building alone weighs around 500,000 tons. But the soil underneath was sandy and weak, completely unfit to support that kind of weight. So what did they do? They pumped over 100,000 tons of reinforced concrete into the ground, mixing it with steel. Then they installed over 190 massive steel supports, known on site as piles badidiene, which acted like deep stakes, anchoring the building into the earth. Each one about 50 meters deep, like burying a 16-story building underground just to hold everything up. With strong foundations in place, the next challenge is to reduce the building's own weight. Even though the Burj Khalifa weighs 500,000 tons, there are no concrete columns or brick walls like you'd find in a traditional building. So what's the secret? Steel. Skyscrapers are built using a full steel frame, which is both incredibly strong and much lighter than concrete or brick. This allows buildings to rise higher without cracking or collapsing under their own weight. If you've ever seen a skyscraper under construction, you'll notice it just looks like a massive skeleton of steel beams. Once the steel structure is done, the rest is just covering it with glass, metal panels, and designing the interiors, rooms, hallways, facilities. But here's one more crucial piece: design. The shape of a skyscraper can significantly reduce wind pressure. That's why you rarely see a skyscraper that's just a boring cube. Look at Taipei 101 in Taiwan. Its structure has a wavy, dynamic design. Or the Shanghai Tower, which is smooth and shaped like a twisted cylinder. Even the Shanghai World Financial Center has a giant hole at the top that allows wind to pass through instead of smashing against the structure. All these features help buildings survive the constant forces of wind and weather. And that's it. If you made it this far, you're a legend. Drop a like so we know how many people stayed till the end. And if you've got a random question that keeps you up at night, drop it in the comments. We might just turn it into our next video. See you next time. Peace.